Hey everyone, welcome to another AP Calculus video, and today I'll be teaching you a little cheat code on what to do when you're dealing with limits, otherwise known as the L'Hopital's rule. So the L'Hopital's rule basically helps us to find any limit where we either get the indeterminate form or infinity over infinity. So L'Hopital's rule states that if f and g are differentiable functions, meaning that their derivative can be found, and f of a is equal to 0 and g of a is also equal to 0, then the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f derivative of x over g derivative of x. So basically we can keep finding derivatives of our top and bottom functions until we can stop getting our indeterminate form. So we can find the first derivative, second derivative, third derivative, fourth derivative, basically as much as the problem allows us to find the derivative. So let's start off with example number 1. We have limit as x approaches 0 of 1 minus cosine of x over x squared. So let's see what happens if we plug in 0. If we plug in 0, we're going to get 1 minus cosine of 0 over 0 squared. If we simplify, we're going to get 1 minus 1 over 0, or 0 over 0. Since we get our indeterminate form, we can use L'Hopital's rule. So we can find the derivative of the top and the bottom and keep our limit statement. So our top is 1 minus cosine of x, and if we find the derivative of that, we're going to get sine of x. And if we find the derivative of the bottom, we're going to get 2x. Now, if we plug in 0, we're going to get 0 over 2 times 0. So we're going to get our indeterminate form again. So we can go ahead and find the second derivative and see if anything changes. So again, we keep our limit statement and find the derivative of sine. The derivative of sine is cosine, and the derivative of 2x is just 2. And notice how now we can drop our limit statement and plug in the 0. So we're going to have cosine of 0 over 2. Cosine of 0 is equal to 1. So our answer is just 1 over 2. Okay, let's move on to example number 2. And here we're actually going to we'll be dealing with infinity. So again, if we plug in infinity for the natural log and for the bottom function, we're going to get the natural log of infinity over infinity to the power of 1/2. Both of these equal to infinity over infinity. So again, we know that L'Hopital's rule can be applied. So okay, let's start by finding the first derivative. So we keep our limit statement. And the derivative of natural log is just 1 over x. And the derivative of x to the power of 1/2 is going to be 1/2 x to the power of negative 1/2. And we can simplify this a little bit. We can keep our limit statement, and we're going to have 1 over x times x to the power of 1/2 over 1 over 2. Again, let's simplify this a little more. We're going to have it gets tricky when you have the negative radical in the denominator. Okay, so we're gonna get x to the power of negative 1 over 2 over 1 over 2, which is just equal to 2x to the negative 1/2, which is just equal to 2 over square root of x. Okay, I accidentally dropped the limit statement, but it's okay. So again, all of this in between is just simplification that you could have done in your head. But in the end, we ended up with 2 over square root of x. Square root of x. And notice now that if we plug in infinity, we're going to get 2 over the square root of infinity. So our denominator is going to keep growing indefinitely because our numerator is not growing. Our numerator is always 2, but our denominator is going to keep growing forever. So, and when our denominator grows forever and ever, that means the limit actually approaches to 0. And so that would simply be our answer. Okay, so now we can try number 3, and we're actually going to solve it two different ways. We're going to solve it using the L'Hopital's rule and logic. So first, let's start by using L'Hopital's rule. So again, we have limit as x approaches infinity of 2x cubed plus 5x over x to the third minus 4x squared. Okay, so yeah, if you notice, if we plug in infinity, we're going to get infinity at the top, infinity at the bottom, so we can start finding our first derivative. So if we find our first derivative, we're going to get 6x squared plus 5 over 3x squared minus 8x. Again, you'll notice if we plug in infinity, we're going to get infinity over infinity, so we can actually find the third derivative. And there's the reason I'm going to teach you the logic method, because it's going to be way faster than doing all of this. Okay, if we find the second derivative, we're going to get 12x over 6x minus 8. Again, if we plug in infinity, we're going to get infinity over infinity, so we can keep going. We can find the third derivative. We're going to get 12 over 6, and which is just equal to 2. So you see, after all this work, after finding 1, 2, and 3 derivatives, we have our answer. But now if we use the logic method, we can actually do this way faster. So you'll notice that if we look at our original limit statement, that if we plug in infinity, we're going to get infinity over infinity. But when you're looking at limits with infinity, you want to look at the leading terms. So the leading term of the numerator is actually 2x to the third and x to the third. So, and you'll notice if we plug in infinity, it's going to be growing at the same rate, because both of it is to the power of 3. And when our leading terms are both to the power of 3, we can actually divide the leading coefficient of the numerator by the leading coefficient of the denominator. So the leading coefficient of the numerator is actually 2, and the leading coefficient of the denominator is 1. So if we divide 2 by 1, we're going to get 2, which is the same answer that we got if we used L'Hopital's rule. So this took us like 5 seconds to do, while this took us like 20 or 30 seconds to do. Okay, I hope you guys succeed on your next calculus test. Have a good day and goodbye.